This is the Module 7 R code video. So in this video, we're going to start looking at how to summarize quantitative data. But before we do that, there's three pieces of information that you need to have. The first one is the R script, and I have that open here in RStudio. You're also going to want to make sure that you have your code book handy. So just as a reminder, this is the code book you want to be using. And then the last piece you'll need is the data set. Now in this video, I'm going to be working with the Kentucky data that we created in the Module 6 video. For your assignments, you'll want to do the same thing, but with the data set that you created for your data, or for your state rather. Alright, so the very first thing I'm going to do is read in that data set. So to do that, I'm going to set my working directory. As a reminder, your working directory just tells R where all the files you need are located. So one way that we can do this is we can actually use this navigation pane down here on the right. So if you make sure that the Files tab is clicked, and then you'll click on these three dots right here. What this does is this will browse through the folders on your computer. So as a reminder, this isn't going to show any of the files, it's only going to show folders. So you could go through here and navigate to where you have your files stored. Once you do that, and I'm going to close it on mine because I'm already there, all of the files in the folder should appear. So you'll want to just double check that you do have that Kentucky data set in here. Sorry, I was actually in the wrong one. So for example, you'll see I've got my Kentucky 2018 BRFSS CSV here. Oh, sorry, the Kentucky 2018 data.csv. I have two versions. All right, so then to set the working directory, you can click on More, Set as Working Directory. That code will automatically populate down here, and then just so you have it for future use, you could always copy and paste it into the script so you don't have to go through those steps again. Alright, so next thing we're going to do is read in the data. I'm going to call the data Kentucky _ 2018 _ data. I'm going to use the read.csv function, and then I'm going to give it the name of the CSV. Make sure you do put .csv at the end, and this is in quotations. And we'll want to make sure that we have header equals true, which tells our the data set that it's going to read in has headers. So this is going to run. Notice up here our data set has been read in. We have 6,604 observations of 275 variables. And that's exactly what we anticipate based off of the Module 6, if you'll remember, when we looked at the Kentucky data that matches. You can use the view function to view the data set, but again, data set is pretty big, so just like last time, I wouldn't recommend this because it is going to slow down your computer, but you can do it. Just be aware your computer might be a little slow while it's pulling it up. Alright, so in the Module 6 notes, we talked about visually summarizing quantitative data. One of the ways we talked about doing that was through the use of dot plots. I'm not going to show you dot plots in this video. The reason for that is the BRFSS data is really large, and dot plots are really useful for small data sets, not large data sets. So in this video, we are going to focus on how to create histograms. I'm going to make a histogram of the num women variable. So the very first thing I want to do is just explore that variable. But before we do that, let's have a look at our code book to look at that variable. So as a reminder, one way to navigate the code book is if you click on the code book and click Control F or Command F if you're on a Mac, that will bring up the Finder, and you can type in the variable, and it will find that exact wording in the document if it exists. So here, notice we've got the num women variable. So what we can see is this variable records the number of adult women in the household. It takes the values 0 through 99, and it does represent the number of women in the household. So this is a quantitative variable. So you do want to be careful when identifying quantitative variables. All of the variables are coded as numbers, but what those actually represent will determine whether or not it's quantitative or categorical. So for example, you might be looking at a variable that records age, and there's several age variables in this data set, but if the variable here represents an age range, then that's not going to be quantitative, that's going to be categorical. Whereas if the value recorded is their actual age, then it would be quantitative. So you really want to be careful when looking at these value labels to determine whether or not the variable of interest is quantitative or categorical. The other thing you want to be careful about is it is possible for some of the quantitative variables to have additional categories at the end, for example, unknown, unsure, refuse to answer. If those are included, that makes the variable categorical. But what we can do is if we set the refused or unknowns to missing, then we could analyze that data as quantitative. And that's, again, if it was a variable like this where it would make sense to do that. If we do set those to missing, then again, we always have to be careful and document that we've done that. And we would say, you know, the refusals and the unknowns were removed and set to missing, and we would say how many of each there were before analyzing that. And to remove those, you would do something very similar to what we did in Module 6. So for this histogram again, we're going to make this histogram for the variable number of women. So let's go and look at the R code. What I've done, well actually before we look at how to actually create the histogram, we do want to see if there's any missing values for this variable. So we've seen this line of code before. Remember, the only pieces you need to change are the name of the data set before the $sign and the name of the variable after the $sign. So if we run this, we can see this variable has 4,251 missing pieces of data. So this particular variable has a lot of missingness in it. If we wanted to see the number of non-missing observations, we could do this a couple different ways. We know there's 6,604 observations, so we could take 6,604 minus the 4,251, or we could use this piece of code. What this piece of code right here is doing is this is essentially just finding the number of observations. So notice if I run this by itself, it will tell me there's a total of 6,604 for the num-women variable. It's just telling me how many total observations there are, including the missing. And then here I'm just subtracting off the number of missing. So if I do that for this variable, there are 2,353 actual observations. All right, so and again, anytime there's missingness, this is something we're going to want to include as a footnote. So as a footnote, like in your actual document for this histogram, you would note that there were 4,251 missing observations. Alright, so we're going to look at a histogram of the number of adult women, and what I'm going to do is we're going to create the same histogram over and over again. I'm just slowly going to change some of the options or add in options so you can see what those do. So the most basic histogram you can make is using the hist function. So just as a reminder in R, if you want to read about any of the different functions, you can put a question mark in front of it and run this, and it will bring up the help, which tells you a little bit about that function and the different arguments it takes. So if you'll scroll through here, you'll see some of the arguments we're going to use in this video. So to start out with, I'm just going to apply the hist function to our variable of interest. And remember, to call the variable of interest, we give the name of our data set, $, variable we're interested in. So running this, you'll see that we get this histogram, and it's really not that great. So let's talk about some of the problems that we're going to try to fix here. So the first one, notice the title here, not too great. You know, we've got histogram of dataset $sign variable. Not that great. Typically we don't want to use the variable names in our plots. Those aren't that informative. We want to say in actual words what they represent. We look down here, our axes, our x-axis, again, doesn't have a very good name. We've got frequencies. We know we really want relative frequencies for the epi reports. And then let's look at the actual bars themselves. Remember, if we look at our code book, that number of women is coded as, well, they're single values. You can have 0 women, 1, 2, 3, all, you know, continuing upward, but you can't have half of a woman or 2.5 women. So what has happened is by default for this particular data set, R has set the bin width to be a half. Well, you can't have half a woman, so that's why you end up with these blank bars, because you can't have data that even falls there. So one thing to notice is really for this data set, a bin width of 1 would probably be a much better choice, and so we're going to see how to do that. All right, so let's slowly make some changes and see what happens. All right, so the very first thing I'm going to do here is I'm going to add in a couple different options. So I'm going to start out with the name of my data set just like I did before, and everything after are going to be different options that I put in. All right, so the first one, main, you've seen this option before. That's what gives you your title. So notice here I've titled this number of adult women in household, and then in parentheses after I've put the number of observations that actually go into making the histogram. And we found that earlier up when we just explored that variable to see if there was any missing values. This piece is going to change the color to blue. This piece is going to change the label on the x-axis, and this piece is going to change based on the count. And I need to take that comment out. That won't be in yours. Oops, sorry, give me just a second here. There we go. So I'll take that comment out on your copy. All right, so let's run this and see what changed. All right, so we're starting to look a little bit better. We've got a nicer title. We've added some colors. We've changed the label here to number of women. We've changed this axis, but we still have some issues. We still have this bin width issue that we talked about. We really still want relative frequency here. So let's add in some more changes and see what happens in the code. All right. So notice here, I've added in a new line of code, which is called breaks. So everything else is the same as previous. So let's run this and see what we get. All right. So notice the breaks, what that did was that changed my bin width. Okay. So changing the breaks, what that does is that's essentially setting where the lines are going to occur. So here, the 0:5, what that is actually producing, if I run this piece by itself, if we look down in the console, that's really producing the numbers 0, 1, 2, 3, 4, and 5. And so it's telling it to place the lines at 0, 1, 2, 3, 4, or 5. Now, for this variable, that makes sense. And let's talk about why that would make sense for this particular variable. To see why it makes sense for this variable, I'm actually going to go back up here, and I didn't run this line of code earlier. I'm going to run the table function on the number of women variable. So what we find here is for the Kentucky data set, there were 262 households with 0 women, 1,820 with 1 woman, and so on. And notice the maximum for the Kentucky data set was 5. So that's why I made the last break here at 5. For your data set, if you had, let's say, the max you found there was 7, you would want 7 for this particular variable. Okay, so going back down to the code. So again, what that's doing is that's changing where these breaks are, and it's forcing it to have a bin width of 1. Now, for other quantitative variables, this may not make sense. So what I'm going to show you next is another way that we could do this. So the other way to make this break, I'm going to put in some code here called how to make breaks. And to do this, we're going to use what is called the sequence function. So what sequence will do is it will create a sequence of numbers, and we can specify how far apart those numbers should be. So for example, if I wanted to make a sequence from 0 to 5, and I wanted them to have a spacing of 1 between them, if we run this, notice I get the exact same thing that I did with the colon. And just like with any function in R, we could look at this function. So we see the sequence here. So notice this first argument is really what we call the from argument. This one is what we call the to argument, and this one is what we call the by argument. So how could this help me figure out how to make the breaks for our histograms? Well, what we can do is really, we know that we want to go from the smallest value in our data set up to the largest. So we could start the from at the minimum of our variable. And we could set the to to be the maximum of our variable. And then for right now, I'm going to leave the by equal to 1. So let's copy this. And what I'm going to do is substitute that in here for where we had the breaks. And this is why I didn't start with this. So let's rerun this. Oops. I've messed something up, so let me double check here in my sequence. Let's see here. Give me just a moment. We'll fix this on the fly. So notice my minimum here. There's one other piece of information I need to add here, and you'll actually see this next week when we talk about means. So what's happening in the minimum function is, since there's missing values here, we have to add in this NA.rm equals true. And we'll have to do this for both the min and the max, because the missing values mess with the calculation of the minimum and maximum. So we run this. Okay, we got the same thing. So again, I'm going to change this, add that in up here, and then run. And notice we get that same histogram. So that's another way that you can do this, and that's going to make that more generalized for other variables. So for example, if you were working with BMI. So what you would do to change this for BMI is you'll use the same code that I have here, and I'm going to leave this code in the script that I give you. Now I am going to change this piece back here. I'll go ahead and do that. Oh. Add these back in. Up here, I am going to change this back to what we had originally, just so you can follow along with the video at the beginning. But again, so how you can make different breaks is edit this sequence function. The only way you'll need to edit it is have the name of your data set, the variable you want here, name of your data set, variable you want here. So you're going to go from the minimum to the maximum of that variable, and then you'll need to choose the by. Now for the number of women, it makes sense to have a width of 1. For BMI, if you make a histogram of BMI, you might want a width of 10. So that'll be something that you'll have to play with to find one that visually works well and summarizes the data well. But that's how you can do that. And then you can just copy this piece and place it into the breaks. Now to make the code easier to read for this example, I'll have the breaks equal to this as we move forward, but just know for other variables, that's how you can make different breaks. All right, so let's keep on going and fix the other things we need to. Notice here, if we look down at the bottom, so if we read this, really what's going on here is this bar is representing all of the zeros, this is the ones, the twos, and so on. And so really what it would be nicer is if we had these ticks here in the middle of the bars. So let's run this. And notice here I've put the ticks in the middle of the bars. So for this particular type of data, it makes sense to have the ticks in the center, since each of these bars represent a whole number. Now for BMI, you wouldn't want to do this. So this is something that you'll want to do, again, if you're looking at variables that take whole numbers or that are counts. So keep this in mind for BMI, you wouldn't want to do this step. But what I've done here in the code is I've set this x-axis equal to n in quotations. If we run this piece by itself, notice what happens is it leaves the x-axis off. And then this piece right here, what this is doing is this is adding those axes back in at the middle. So how you would change this is here, or pardon me, up here, what I've done is I've assigned the histogram to be equal to an object. I didn't do that before. So set the histogram equal to be an object. So in this case, I'm making a histogram of number of women. So I've set it equal to hist.women. Then down here on the axes, you'll refer to the name of the histogram, $mids. So that $ mids, that part doesn't change. That's pulling the midpoints from the histogram that you created. And then your labels, this will be equal to whatever you had here minus 1. So it's forcing it to move down 1. And again, you'll only want to do this for whole numbers. And again, and if these counts are of a low value, so in this case, the maximum count I had was 5. If your maximum count is 100, you probably still wouldn't want to do this. You would use a different binning, and so you would want those breaks, the ticks to go right along with the breaks. So this is kind of a special case for this variable. You won't always want to do this step to move those ticks to the center. And then the very last thing we need to do here that I'm going to change is, remember, we don't want counts here. Really what we want are relative frequencies. So to do that, the only piece you need to add in is frequency equals false. And if we do that, remember, we're going to want to change your y-axis label to relative frequency. So running these all together, we get a nice plot of the number of adult women in the household. Now, again, for some variables, you're not going to want to put these tick marks in the center. So for example, if we go back up here to where we didn't have the tick marks in the center, you'll notice that if I add in that freq equals false up here, we're still going to get relative frequencies. And again, I would want to change that y-axis to stay relative frequencies, not count. All right, so just to kind of summarize as we go through here what the different pieces were and why we did them. We read in the data set. We explored the number of women, and so the reason we wanted to do this is this gives us an idea of how many missing observations there are. Also, the table gives me a good idea of the types of values this takes. Now, I would not run the table on a variable like BMI, because again, BMI takes a lot of different values. It's got a really big range. This table is really only useful for quantitative variables like number of women that are counts where the maximum is fairly low. Next, to make our histogram, we use the hist function. So this is the most basic histogram we made. So the first thing we saw to change here, some options to add are options like titles, axes, and the color. Next, what we saw here was how to change the breaks if we need to. Again, for a variable like BMI, you might not have to, but when we're working with these count variables, we want to make sure our breaks are in whole numbers. So here we've done that by adding in this piece of code right here, breaks equals. We saw here how we could make different types of breaks using the minimum and maximum of the variable and then specifying what our actual bin widths will be. Finally, we saw if we wanted to, how to move the ticks to the center of the bars, and again, only useful if we're looking at variables that really take counts and they're a low number. So if you're looking at number of women in a household, number of men in a household, things like that, you would want to move that to the center. So you don't always have to do this piece. And then the last piece that is really important is adding in this frequency equals false argument. That is what's going to give you those relative frequencies or those percentages on the y-axis. So as always, if you have any questions, please let me know, and I hope that you have a wonderful week.